Okay, so this is an example of a USGS topographic map. USGS stands for United States Geological Survey, USGS. And they're the organization that is responsible for creating all the official topographic maps. So a topographic map has a lot of information jam-packed on a small space of paper. So we use a lot of symbols and a lot of those sort of tricks to read the map. So first, I'm going to zoom in at I'm going to go at the top, I guess. I'm going to start at the top. And I'd say usually the name is at the top, but not necessarily. So when we're looking for the name, we're actually looking for the word quadrangle. It's not always going to be at the top. It's not always going to be in the center. So the key word you're looking for is quadrangle. So this is Booth Bay Quadrangle. That's the title of our map. This also tells you it's 15-minute series. That means there's a 15-minute distance between the top and the bottom of the map. What do I mean by 15 minutes? Well, if we look at the Earth is a sphere, and there's 24 hours within that sphere. It takes 24 hours for the sun to go around 360 degrees. So that's how we get our degrees. We have 0 to 180 degrees longitude, east, and then we also have it west. 180 plus 180 equals 360. So that's how we get our degrees. And we can break those degrees down into minutes. There are 60 minutes in a degree. Just like there's 60 minutes on the hour, there's also 60 minutes in the degree. And just like a clock, if we break 60 minutes down into 60 seconds, we can do the same here. 60 minutes has 60 seconds in it. So it kind of sounds like time, but it's actually more like a distance. I'm in the upper right-hand corner, which would be the northeast corner of the map. And you see two numbers. This is 69 degrees and 30 minutes. This is 44 degrees and 0 minutes. So that's a location. Now, which one's latitude and which one's longitude? If we were to draw a symbol of a ladder, just like this, the long pieces of my ladder are my longitude. And then the flat pieces of my ladder are my latitude. So the long pieces are the longitude. They're going to go, one line of longitude is going to go from the North Pole to the South Pole. My latitude line is going to run like the equator. So this is my latitude line. It's horizontal. So I'm going to follow this line over until I get to that 44 degrees 00 minutes. That would be my latitude. And then follow this line up. That's my longitude until I get to 69 degrees and 30 seconds. Now, another thing to look at, a little memory, is how do we get, I mentioned we got our longitude from 360 degrees in a circle. But with our latitude, it goes, our latitudes are horizontal, so that's our equator, and our equator is 0 degrees. And if I draw a line straight up to the North Pole, that gives me a 90-degree angle. So 90 degrees north is made by that 90-degree angle. If I were to cut the Earth in half, I'd make a 90-degree angle. Lidditz is at 40 degrees. So if we were to draw about a 40-degree angle, so just shy of 45, that would be Lidditz. So that's like a 40-degree angle, so Lidditz would be right there. So our latitude is going to go from 9 degrees north to 0 to the equator, but then 90 degrees south. Another way to double check your latitude and longitude numbers, if this line again represents my longitude, the line here should have the same number at the top and the bottom because it's representing the exact same line. So 60 degrees, 30 minutes at the top. Let's slide down to the bottom of the map. And you'll see 60 degrees and 30 minutes. So that number matches. My latitude line, you'll notice, changed. That's because I went from north to south. Okay? Now, let's look at our minutes. We can divide our map into R blocks, is what they're called. So I'm going to look down here. Remember, our minutes are represented by the little tick mark. So I'm going to look down here till I find another tick mark. There's 55 minutes. So I'm going to take a ruler, or you can use a string or anything, and I'm going to put a line at that 55 mark. And if I follow that 55 mark on the other side of the map, you'll see the 55 is over here as well. Okay, so that's one line. And I'm going to keep going down until I see another tick mark. And there's 50 degrees right here. And again, if I look on the other side of the map, I'll find 50 degrees. So I'm going to put my ruler, or paint stick as it is, there. And we can do the same for our longitude. So again, I'm going to look for these tick marks. There's 35 minutes, and if I follow that spot all the way to the top, I'll find 35 minutes again. And I'm going to keep going until I see another one. Here's 40 minutes. Okay, now I'm going to zoom out on my camera, make my camera bigger, so you can see what I did. And now you'll see we have 9 sections of this really big map. And it's just like reading a book. Top, you start at the top and you go left to right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have these 9 R blocks. This is an easy way to find a location pretty quickly. So if I say something is in R8 northwest, 1, 2, 3, 4, 5, 6, 7, 8. So within this little block, I'm going to go to the north and the west. So I can look in this region here and find something really quickly. Some other terms you might see, I might say central. So that doesn't necessarily mean the center of the map, but if I say R8 central, it's going to be in this block, but in the middle. Or north central, this would be northeast. So those are your R blocks. Next, I'm going to zoom in down here at the bottom of the map. The bottom of this map has a lot of information. So here are some symbols. So this is your legend, what a heavy duty road looks like, medium duty, etc. So we can take a look here for some symbols in our legend. This tells you the date the map was made. So this is 1957. This is important sometimes because our magnetic North Pole moves around. So we need to know the date that it was created so we can correct for that movement. Over here is a state, an outline of the states. We're in Maine. And the little box in here represents where specifically our map is located. So it looks like our map is sort of in the southwest section of Maine. So I may ask, where in Maine is this map located? You look down here and say southwest. Moving on over, we have the scale. Now there's a couple of scales that we can use. This first one is the fractional scale. Notice there's a ratio, a fraction, 1 to 62,500. What that means is 1 inch on our map. And so if I measure an inch here, from 5 to 6, 1 inch on the map is going to equal 62,500 inches on the actual Earth. Now that's a really big number, so you could divide it by the amount of inches in a mile to get the exact amount. We can, however, just use our ruler and line up 1 inch on our map. I'll put the edge of my ruler at the 0. Notice the 0 is not over here at the edge. So let's put it at the 0 and line it up. And you'll see 1 inch equals about 1 mile. On the left-hand side, notice how this big box is sort of broken down into 10 smaller boxes. So since there's 10 smaller boxes from 1 to 0, that represents 1 mile, each boxes represent 1/10 of a mile. Now if we're going to do kilometers or feet, we have kilometers and feet down here, but we're typically going to use either miles or maybe the kilometers, but for maps, typically miles, since we're the United States and we tend to use miles. Okay, I'm going to come back to that, but while I'm down here at the bottom of the map, I'm going to pay attention to this. This tells you 3 different North Poles. Did you know that we have 3 different North Poles? Maybe that's why we can't find Santa Claus. He's probably one of those 3. Okay, so the star represents the North Star, Polaris. So that's where, if we look up in the night sky, that's the direction that the North Star would point. GN stands for the geographic North Pole. If you look at a map, all of our longitude lines are going to follow up to the North Pole, and it's going to connect to the South Pole. So the GN, geographic North Pole, is where all the longitude lines are going to intersect on our man-made imaginary line and our imaginary globe. MN, this is important because MN stands for the magnetic North Pole. So if you're using a compass, my compass isn't going to point to the geographic or the North Star. It's going to point to the magnetic North Pole. Magnetic North Pole is created by the liquid iron in the Earth's core. And since it's a liquid, it moves. So our North Poles actually move. It kind of wanders around up at the top of the North Pole a little bit. That's why we need to know the date, so we know how many degrees off it is from the geographic North Pole. Now, in order to find the difference, it always tells you 2 angles. If you'll notice this dotted line here, let me zoom in. The dotted line tells you what the angle is representing. So this dotted line represents 18 degrees. The GN to the North Star represents 26 minutes. So if I want to find the difference between the geographic North Pole and the magnetic North Pole, I just have to subtract these 2 and I'll be left with the smaller angle. So if you're going to do that, make sure the the units are in the same units, because this one's in degrees and this one's in minutes. But we can make that conversion. How many minutes are in a degree? The correct answer is 60. So all we have to do is take 26 and divide it by 60, and that'll give us degrees. So if we do that, this would actually equal 0.43 degrees. Now we can make an easy subtraction. 18 minus 0.43. And that'll give you the angle between the magnetic North Pole and the geographic North Pole, which is usually what we're looking for. Now sometimes, move to a clear spot, they might be separated like this. This might be the magnetic North Pole and this might be the geographic North Pole. In this case, they'll give you this angle and this angle. So instead of subtracting, we will have to add the 2 numbers. Next thing I'm going to show you is distance. Let's say I'm going to go I'm on a canoe, and I'm going to go from this island to this island. I'm going to put my ruler up here. You can use inches or you can use centimeters. It doesn't matter. I like to use centimeters because I find it a lot easier to read, but that's just me. It does make it a little bit easier if the scale is 1 inch equals 1 mile. It does make it a little bit easier to use the inch scale maybe, but it's not always 1 inch equals 1 mile. So I tend to just go with the centimeters. And if I look here, looks to be about 1.7 centimeters. So I'm going to keep it in my head, 1.7 centimeters. Now I'm going to line it up on my scale. So 1.7 centimeters would be about here. Notice it doesn't really line up with anything exact. I could estimate, but this is where this scale over here is going to come in handy. So I'm going to slide my ruler over to here. I'm going to count the tenths. So I have to go to 1.7, so I have to go to here. So there's 0.5, 0.6, 0.7. So if I'm going to get in my canoe, it's going to be 0.7 miles from here to here, 7/10 of a mile. Now, let's say I'm doing a really big distance. Let's say my distance, if I measure it on here, it comes to 15 centimeters. Notice how it goes off the scale. this is what I'm going to do. I'm going to use the scale, and this is 1, 2, 3, 4, 5 miles. Remember, it kind of goes backwards here, but that's a total of 5 miles. So I'm going to put my finger right here. I'm going to keep 5, remember 5 in my head. I'm going to slide this over until I'm at the beginning of the scale over here. And then I can add another mile because the 15 lines up with the 0. So that would be 5 miles, I'm sorry, 6 miles total. A couple more things. Let's look at the topographic lines. A couple of things with topographic lines. Let me zoom in on a location. Let's say I want to know, where am I at here? What the height of the center of that hill is. There's no contour lines here, so I need to find a line that has a number next to it. Like here's 100. The bold lines represent every 5th line. And I guess I forgot to mention our contour lines also usually listed down here with our scale. It says our contour interval is 20 feet. So every contour line represents 20 feet. So if this is 100, I'm going to probably count up because this is the water. Water is always downhill, so I'm going to count up. I'm going to mark it just so it's a little easier to see on the map. So there's 100. That would be 120. 140. So this line here represents 140. I'm going to outline it because I can erase it. I'm going to know what's in the middle of that hill. I know it's not going to be 160 because that would make another contour line, and it's not there. I know it has to be greater than 140 because it's not on that line. So you're going to estimate in between, maybe 150. I would accept that. Something else to look at are rivers. Okay, so we're going to look at this blue line that represents our river. Now we have to look at our our contour lines that cross the river. So I'm going to outline, this is a really big one. We're going to look at that contour line, and the V, the point of the V is going to point uphill. So here's the point, and it opens up this way, so this is pointing uphill. My water is going to go flow out of my V. Did you ever see those cups in waiting rooms or cones? Right? Here's the point of my V. My water is going to flow out of my cup or out of my V. So in this case, my water is flowing south. And another question I'll often ask is the steepness of slopes. So if I take a look at that mountain, what side is steeper, the north or the south? Notice how the north is really spread out, and the south, those lines are really clumped together. That means it's steep on the south side and a more gentle slope on the north side. Also at mountaintops, if you see like a little triangle or sometimes it's an X, it'll tell you the exact elevation. So in this case, this exact elevation is 321 feet. So usually on like really big summits or some of the highest locations on the map, it'll give you the exact location. With the highest elevation, I'm not sure where the highest elevation is off the top of my head looking at this map, but let's assume it's this elevation, 320 feet. To find the relief, you're going to find the lowest elevation. Well, if we take a look, this is the Atlantic Ocean. So the Atlantic Ocean is going to be at sea level, which would be 0 feet. So in this case, for the relief, you take the highest elevation, which is 320 feet, minus 0 feet. That would give you the relief of this map. So the relief would be 320 feet from the highest point to the lowest point. That's going to give you a rough idea of how steep the mountains are, or if it's really flat, like plains. And typically, if there's not a very large relief, you're going to have a very small contour line interval. If you have a really steep mountain, the contour interval might be 100 feet because it would be too crowded to put all of those lines together. Okay, that pretty much sums up how to read a map. Now you're going to have some practice reading some maps and going over some of the stuff that I just outlined.